everybody. This video is for our speeds and feed assignment. Very first assignments in learning about milling, how to kind of calculate how fast your tool should be spinning and moving while you're milling and using our milling machine in class. To talk to you guys about is, what does tool look like that's milling? So this is called a 4-flute ball mill. It has 4 cutting surfaces. So we have 1, 2, 3, 4 cutting surfaces on this guy. And that is actually going to give us, that's actually going to allow you to cut faster than, say, a 2-flute ball mill. So there's four blades on there. So 4 is obviously going to be able to cut twice as fast as 2. I'm going to show you how to calculate some things as speeds and feeds. Again, this is just really basic intro to our first steps in using a CNC machine. I also want to talk to you about first cutting speed is kind of the rate of the tool. That is kind of self-explanatory, but this one you would have to have some other background. So I wanted to just kind of explain what those two definitions mean. If we're talking about this tool, if we're talking about the spindle speed is how fast is this tool turning, okay? So is it turning at 1500 RPM, or is it turning at 3000 RPM, depending on what you're milling? Spindle speed is how fast is this turning, right? And then feed is how fast is it moving while it's turning? So is it moving at 50 inches per minute, or is it moving at 100 inches per minute? Whatever it is, it really depends on the tool that you're working with, as far as what are you milling with, and then what the material is that you're also working with. So I'm going to show you those calculations. They're not really that crazy, but you do need to be able to read our formulas down here, and they look a little intense, but they're really not that bad. So I just wanted to break down what these formulas actually mean, and then how do you use them. Go over a couple of the problems before I send you off to do your own problem. First of all, cutting speed. So CS, cutting speed. This is standardized in your problems. I'll give you your cutting speed. I'll give you the diameter, and then pi is just pi. So the only thing that really you need to know new here is cutting speed. And then this 12 inches in a foot, that is just a conversion. They give the cutting speeds in feet per minute, and in spindle speed, we need to know the inches per minute. It's really just a conversion happening here with this multiplying by 12. So it's nothing there's nothing too crazy. It's just, you've got to get used to using the formula and reading the formula. Same thing goes down here. Feed rate in inches per minute. Again, feed is fast your tool is moving across the part. The spindle speed is how fast it's spinning. Here's a couple of the tools that you may be using in class. So we have a cut end mill, we have a ball end mill, we have the differences in the number of flutes. We already talked about that. So this is 4 flutes, this is 2 flutes, and then there is a 4-flute non-center cutting. So this one would not be cutting down the middle of it. This does cut down the middle. So you can't really drill a hole. You can really only come in from the side on this one. We don't use this one in class, so you don't have to worry about it too much. This is a really good PowerPoint to familiarize yourself with. I'll post this in our lesson as well. But I want to get back to this, because this is really what your assignment is all about, right? So we have first calculations. First thing I'm going to ask you guys to do is start calculating cutting speeds for high-speed steel cutting tools. Feet per minute for aluminum, 250 feet per minute, and then 90 feet per minute. So steel is, so you can go faster through aluminum than you can steel, and that's really kind of the idea behind any of the materials that you're using. Softer the material, the faster you can move. The harder the material, the slower you have to move. So we have our first two that are going to be calculated using 1/2-inch end mill, assuming that let's just assume that it's an end mill. We want to know what our spindle speed. Kind of in general, we're going to think aluminum is going to be a faster spindle speed than steel. We should see a larger number here than we should here. Let's just start off with our calculation. We're looking for N. So N equals our cutting speed. So our cutting speed is measured in feet per minute, and that is our cutting speed here, 250 feet per minute, so that's 250. And our conversion ratio of 12 inches in 1 foot. So this is 250 feet per minute. This is 12 inches in 1 foot. Those are going to make a 1 there, the feet over feet. And then pi times the diameter of our tool. Well, here's the diameter of our tool. So we have 0.5. We're going to grab our calculator, 250 times 12 inches. So we're at 3,000. And we're going to divide that by pi. So we can estimate pi at 3.14. We also need to divide it by 0.5. Divided by our spindle speed for this one is 1910.8. We could round it to 11 if you wanted to. So in revolutions per minute. So when you start milling, you're going to use this number. Like this is an actual number that you use and tell the machine how fast to spin. So you'll learn how to program it a little bit later, but first we need to kind of RPM. So steel, we should see this being a smaller number. I'm just going to work on this one. This will be the last example I do for you guys. The cutting speed is 90 feet per minute. So we'll say 90 feet times 12 inches in a foot. And we have pi times 0.5. 90 times 12. So we have 1080. We're going to divide that by pi, and then we're going to divide that by 0.5. Okay, and so we get 680. We'll call it 88 RPM. I'm okay with you rounding it to the nearest RPM. Second thing you're going to have to do is calculate the feed rate when milling aluminum with a 1/4 inch end mill, providing that the feed per tooth is 0.02. Now we're going to calculate the feed rate, which is different than the speed rate. Remember, speed rate is how fast it's spinning, and then feed rate is how fast it's moving across the part. To calculate your feed rate, you do need your spindle speed. So you need to know your N, which is what we're calculating up here, right? So to do that, I'm gonna lay out the formula for you here. So we have feed rate, okay, our F of M equals F sub T, which is feed in inches per tooth per revolution, and that's this guy, our 0.002 inches. Our 2007 inch, and then times our N sub T, which is our number of teeth, times N, which is our speed rate, which is what we've actually been calculating up here. So the first thing you got to do is figure out what your N is. So we're working with milling aluminum, and we have a 1/2 inch end mill. Okay, so 1/2 inch diameter end mill, and we're milling aluminum. And those are really the two things that we need to know to figure out what N is. So you're going to take your formula that we just were working with, and we're working with aluminum, so that's 250. 250 feet, and that's our cutting speed. And then we have our conversion, which is 12 inches in 1 foot. And then we have pi, and it's 1/4 inch end mill, so that would be 0.25 inches. All right, so this is going to give us N. So we do 250 times our 12. So 250 times 12, and that gives you our 3,000. Feet is gone, so 3,000 inches. Then we have pi, 5, and we get 0.785 inches, and then we do 3,000 divided by 0.785. Okay, and so our spindle speed is 3,800. 3820, we'll round it to 3822. Okay, so we're going to take this number and we're going to substitute that in for our N, right? So now we have our F of T, or F sub T, not F of T. Our F sub T. So our F sub T is feet and inches per tooth revolution. Okay, so that's our 0.002. So we're going to say 0.002 times the number of teeth. So we're going to put in, we have a 1/4 inch end mill, feed rate per tooth, and it's 4 flutes. So that's 4 teeth. So times 4 times 3822 RPM. We just straight up multiply. I already have my 38.2 in there. So we're going to say times 0.002 times 4 and feed rate of 30 inches per minute. Okay. So you guys have any questions, ask me in class. Honestly, I kind of gave this one to you. There's only one question about this, but everything is pretty much standardized once you've figured it out one time. So we do use really conservative numbers in here. So everything is going slowly. It's going pretty slowly in our class just to A, keep the tools safe, and B, keep you guys safe. So we're not really pushing any of the tools to the limit here. So you do need to do the rest of the calculations, and you do need to do the conclusion. No.